In today's lesson, we'll be learning about rate of change and initial value with a focus on graphs. In our first example, we have a situation where as your number of tickets increase, your total cost increases as well. On our x-axis, we have number of tickets, and on our y-axis, we have total cost. The initial value in this particular situation is $0, since it costs $0 if you buy 0 tickets. However, the rate of change is a little bit more complicated. You'll notice an increase of $20 for every 4 tickets. You'll notice this pattern being repeated again and again. Many of you would say that the rate of change is an increase of $20 for every 4 tickets. However, this wouldn't be the most accurate statement. Why is an increase of $20 for every 4 tickets not the most accurate way to describe the rate of change? Well, simply put, no one cares about how much 4 tickets cost. You want to know how much 1 ticket costs. Now, using mental math, you can figure out that 1 ticket is going to cost $5. Therefore, the rate of change is actually an increase of $5 for every 1 ticket. The information in the graph can also be represented with an equation, y equals rate of change multiplied by x plus initial value. We just determined the rate of change to be an increase of $5 for every 1 ticket. Now, 5 over 1 is the same thing as 5 divided by 1, which is the same thing as just 5. Therefore, the rate of change can be simplified to just 5. Meanwhile, the initial value is $0, since if you buy 0 tickets, that will cost you $0. Therefore, the initial value can be written as just 0. So this situation can be represented with the equation y equals 5x plus 0, where y represents your total cost, and x represents your number of tickets. In our second example, we have a situation where the temperature is decreasing as time increases. On our x-axis, we have time, and on our y-axis, we have temperature. The initial value in this situation would be 100 degrees Celsius, since that is the temperature when your time is 0. However, the rate of change is a little bit more complicated. You'll notice that there's a decrease of 20 degrees for every 5 minutes. This pattern repeats itself again and again. Many of you would say that the rate of change is a decrease of 20 degrees for every 5 minutes. However, this wouldn't be the most accurate statement. So why is a decrease of 20 degrees Celsius for every 5 minutes not the most accurate way to describe the rate of change? Simply put, no one cares about how much the temperature is decreasing for every 5 minutes. I want to know how much the temperature is decreasing for every 1 minute. Now, using mental math, you can figure out that there's a decrease of 4 degrees Celsius for every 1 minute. Therefore, the rate of change would actually be a decrease of 4 degrees Celsius for every 1 minute. The information in the graph can also be represented with an equation, y equals rate of change multiplied by x plus initial value. We just determined the rate of change to be a decrease of 4 degrees Celsius for every 1 minute. This is the same thing as negative 4 over 1, which is the same thing as negative 4 divided by 1, which is the same thing as just negative 4. Therefore, the rate of change can be simplified to just negative 4. We also determined the initial value to be 100 degrees Celsius, since that is a temperature when the time is 0. Therefore, I can put 100 as my initial value. Therefore, this situation can be represented with the equation y equals negative 4x plus 100, where y represents the temperature and x represents the time.